Hello and welcome to another tutorial. So this time we're going to be continuing to extend the weather effects system. So we set that up with being able to play some basic effects. We then set up so we could have presets. So a pre-configured set of things like the rain and fog and hail and stuff like that it would then go and activate. So what we want to add in today is being able to change the sky in relation to that. And a similar thing related to it, because it all sort of feeds in for creating the effect we're after, we're also going to set up so that we have both a sun and a moon, and that there is a time of day that is going and controlling the positioning of those. So it's going to be the key stuff we get set up. So let's dive on in. Now, one of the ways that we can work with the clouds is there is a setup called volumetric clouds. And so what I'm going to do, just as an initial sort of test, just to see how it works, onto the fog one, I'm going to temporarily change the fog weight up to 1, but turn the fog off. Let's do that. So under overrides, if we go down to sky, then we have volumetric clouds. Now, when we add that, this error here is likely going to be what you see to begin with. Unless you're already using volumetric clouds in the project, odds are you will see this error. And it can be a little bit of a tricky one to sort of track down. So I'll show you the different areas where you need to look for this setting, because there's actually a few potential areas that you might need to change it. So if we go to our project settings, then under graphics, we have these HDRP global settings. And if we scroll through here, what we're looking for is these frame settings. So these control things that are applied to the particular camera. So under lighting, we want to just come down and check that volumetric clouds is enabled, which it is. So that's good. So that's on the HDRP global settings. Then we need to change things on the HDRP asset as well. So if we go to a particular asset, so we've got asset here and we can select that. And again, under lighting, you can see we've got volumetrics and we can turn on volumetric clouds, but we'll notice that error is still there. That's because the HDRP asset, we actually have different ones for the different quality levels. So under your project settings and quality, if you go to HDRP, you can see it lists the different particular ones, and we can actually select those here. And you'll see under these, they also have that volumetrics clouds one that we have to turn on. So I'm just, for now, this is something where you might want to configure it per pipeline, per sort of quality mode. So some ones you might not want to have that turned on for. I'm going to turn that on for all of them though. And with that, we now have access to these cloud settings. So we can turn that on. And then cloud control, we can go with simple cloud control, and we can switch between different presets. So we have sparse, we have overcast, things like that. So we've got a lot of different ones that we can be using. We can also go for custom setups where we can adjust all of these different sort of sliders, everything like that. Now we can go even further. We can switch to advanced cloud control where we can be providing in particular texture maps, things like that. You can also go manual where you're then providing sort of the lower level detail again. So I'm going to stick with using simple for this. And I'm going to stick with using the presets. Now that does come with a couple of limitations. One of the main ones is the clouds are all or nothing. So we can see when we change the slider here, they will fade in. So there is a fade in that happens, but it is something where they are either there largely or not there. So it's not something where we can do sort of a balance between the different types of clouds. If we wanted to have that, we would need to do something where we were actually changing the lower level settings there, which would be possible. But for this, we're not going to do that. And we can kind of get away without doing it. We actually don't overly need it. So I can turn this off and I can turn the fog back on, and I'm going to lower this. So, okay, I need to set up a volume that is going to be controlling my sky. So I'm going to add in one of our volumes, and it'll be a global volume. So we'll have sky. I'll create a new volume profile. So I want to make sure that this is positioned alongside where we've got the VFX one there. By default, it will have created it in here. So I'm just going to move that over to our VFX and rename that. Sky volume. So we have our sky volume set up there, fog one, that's fine for it being as it currently is there. So our sky one, we can now go back and add in sky and volumetric clouds. We turn on the different settings that we know we are going to need. So that looks good, those are working. So what we ideally want to be able to do is change that preset in code. So to do that, we need to do a little bit of reverse engineering. We need to figure out, okay, where is that setting actually coming from? So we might be able to get stuff from the help file for it, is something where we might be able to actually get that information. The other option that we've potentially got is we can actually have a little bit of a look at the code. Now, these things, to get to the code of them, is a little bit involved. So if we select the profile, if we come up here and turn on debug, that actually lets us see the scriptable object that it's linking to, which double-clicking on that takes me to the actual thing. And then I have access to the script. So we can see we've got things like our cloud control, and we can see in terms of what we're looking for is our presets. So we can see what our presets are called, so that's good. That means that in our weather preset, we could actually set up that, because we know here's our namespace. The class, we've got access to that. The cloud presets is public. So what I could be doing here is with this, I could have a public, and we haven't already brought in the namespace here. So we haven't already brought this in. I'm going to actually bring that in just to avoid having a variable name that is going to be a ridiculous length, because it would be an absolutely ridiculous length. So then we can do volumetric clouds. We can go cloud presets, and we just check and make sure that that was the particular one, and it was. So then we can go cloud preset, and we'll default that to sparse. So that will allow people to configure it in the actual individual presets, which is good. So I can go now to our data for the different things. So there's something to remember when you're working with something that's a package, generally you're going to be able to access the code for it. We will switch back to regular mode. So now, clear skies, that can go with sparse. Heavy rain can go with stormy. Light rain can be overcast. And light snow can be cloudy. So that will be good. Now we need to know what parameter we have to go and set in that volume. And we're going to also need access to that particular volume. So we've updated the preset, but then our weather manager needs to be able to keep track of those particular volumes. So it's going to need serialized field, a volume, and it's going to need the sky volume. And then when we switch preset, so this is going to be something where we've got our update, and so we've got our change weather. So when we do change weather is when we want to actually change the setting for that volume. So we can see here how we adjust things with our fog component, stuff like that. We have this cached one. So we're going to actually need that with the volumetric clouds. So we're going to have volumetric clouds, cached cloud component. And I might actually rename that to cloud volume. So that cached cloud component, we need to be able to retrieve down here. So we're going to have f cached cloud component is not equal to null. Then we will do a little bit of configuration for it. We're also going to do cloud volume, profile, try get, and we're going to try and get the volumetric clouds. And that goes into our cached cloud component. So that looks good. And if we do retrieve it, then we'll go and do some updating. The other thing I want to do is cloud volume weight, just force that to 1. We don't, it changing from different values is kind of meaningless for us. So the cloud component, we then want to be able to set that preset. So again, because we've discovered the code, we know that there's this cloud presets parameter. So we're looking to see where that actually is created down here. So that should be one of the variables here. So we can search for cloud presets. So we can see the parameter that's been defined there, and we can see cloud preset. So, okay, that means we should be able to go and say, well, cloud volume, the cached cloud component, and the cloud preset, we can go override, and we can give it the new preset that we want it to be using. So in this case, we'll default it to sparse clouds. And this same line, when we come down here to changing the weather, we would then change this to be using new weather and cloud preset. Now, if we were wanting to, again, have a very gradual transition, we could essentially do a blend from a whole set of old parameters to a whole set of new parameters. And we can see here what the different types of ones are. We would also be able to dig into, okay, what does a cloudy preset look like? What does it actually have those various sliders here configured to? And then blend between those. So we could do this as a much more gradual change if we wanted to adjust lots of different sliders. But what I've found is, especially once you've got bits of fog and things like that in there, people don't really notice the cloud transition overly. So you can kind of get away with just a hard switch, but it depends. If you're doing sort of a very, very slow gradual transition, you would need to then potentially sort of migrate, you'll sort of loop each of those individual parameters. So our VFX set, that's all good. Our weather manager, we need to link up the cloud volume. And then what we want to do is we want to just test, okay, we're currently, the default will be light snow. I want to make the target heavy rain. And then we'll run it. We should expect to see the clouds change a bit, which they have. And if I switch it then to heavy rain, so we get a pretty rapid transition of the clouds there. But again, as I said, we could actually go and animate the individual parameters. If we go to clear skies, then that's going to clear everything up nicely. Takes a bit for obviously the rain to fade away. If I switch back to the rain, we can also take a look with the sky volume. We do actually have other settings here. So we can do things where it's going to actually adjust stuff like our lighting. So if we do things here where like our sunlight dimmer, that you can see it darkens the sky a fair bit more. You know, our ambient light probe one will darken things again. So depending upon the level of intensity that you're wanting here, you could also adjust those settings too. So those could be things that we apply with it. So those could be a handy one, and we can see the settings here, ambient and sunlight dimmer. So we could go and add those in. So what we would add in is, and I'll put this in its own separate area, cloud configuration. We'll have a public, and this will be a range 0 to 1. Sunlight dimmer, which default it to 1. That's sort of the setting that it seems to use. And we'll also have ambient light dimmer. So that looks good. Then over in our weather manager, again, that's something where at the beginning we want to make sure that we're able to override these settings. So we have to go and do this override line. Hash cloud component. And what we would go and do is we would go sunlight dimmer override to 1. This enables the setting to then be changed later on with us just going set value. So cached cloud component, ambient light probe dimmer, override 1. So that will mean that that's able to be modified later on easily. So we've made sure that these settings are able to be overridden. So now we can apply them when we go and change the weather. Now we could blend these, but because we're doing a hard switch of the actual clouds, and I think it makes sense to keep the light change in sync with that. So if we're doing a gradual change, then yes, we would actually blend these through. But because we already have no choice but with using the presets for it to be a hard transition, I'm just going to keep these with them being a hard transition. So we can go value is new weather and sunlight dimmer. That actually, this here should be value equals. It'll work if you do override again, it's just a little bit redundant. So I'm going to do cloud component, ambient light probe dimmer, value is new weather, ambient light dimmer. So that's good. That means what we can do is for stuff like really heavy rain, I can drop those all the way down. For light rain and light snow, I'll put those at about 0.5 each. So that will mean that we see a little bit more of a impact from when we're going and changing the actual light here. So we're going, we'll switch to heavy rain. So it's a lot darker, which is good. And we could also be varying the actual directional light intensity, which is a nice segue over to, well, at the moment we've got a sun in here. What I want to set up is so that we have a sun and a moon that both can sort of move and that we're able to be controlling that. So what I'm going to do is we've already got our physically based sky here, which with that, as I move the sunlight around, you'll notice we get that sort of properly changing, but when it's night, it's super, super dark. So what I want to do is I'm actually going to clone that, call that moon. You'll generally see this error about only one directional light can cast shadows, so I'm going to turn off shadows for the moment. Bring this up here, and so sun's angle is currently 0. I'm going to change that to like 30, maybe 45. Or let's actually, so we'll ramp that up to, that's right, because we've got 2 suns in there. So we'll make that 20 degrees for now. The moon, I'm going to make that 20 plus 180, so it's exact opposite side of the world from it. And this light intensity, so at the moment we're at 130,000. I'm going to drop that to about 0.5 for the moon. Sun is about right. And then what I'm going to do is I'm going to create an empty parent. Sun and moon system. Or just sun and moon. Because what that then will do is I can rotate it. So we get our sunset. And then the moon will be up. So we're getting a little bit of light, not a huge amount. And as we angle sort of sweeps around, the moon should come into visibility. So we've just got the moon visible as we're just starting to see sunrise. So now we have something where we can have sunset, moonrise, things like of that happening, which is good. So we've got something we can be controlling there. We do have to wrangle with the fact that, okay, only one of these can be casting shadows at a particular point in time. So we want to make sure that works. So what I'm going to do is I'm going to set up with the script. I'm actually going to have the weather manager control this, because sun and moon feels like it's something that's appropriate for the weather to be controlling also. So we've got our different sort of settings here. Going to have a header for what this will be is sun and moon. So we're going to have a transform for the sun and moon system. But then I need to also be able to turn off shadows and control things like of that. So for that, now you would be used to, if you were working in the built-in pipeline, you would just work with the light directly. With this, we need to actually be using this HD additional light data. So we have to actually work with that. HD additional light data, moon light data. So those are the specific ones we have to actually work with for this. So when we get our weather manager here, we should be able to link up the different ones. So we have our sun and moon linked up. We link up the sun and we link up the moon. So we need to do that if we want to adjust intensity, things like of that. I'll actually call that time of day. And then what I'm going to do is have a float that controls how fast time passes. So time multiplier, which I'm going to default to 90. So 90 would mean that in 1 second of real world time ends up being 90 seconds of in-game time. So I'm going to have the time multiplier. I'm also going to have hours per day, which will default to 24. I'm going to have a sunrise time, which I'll say is 6 a.m. and a sunset time, which I will say is 6 p.m. Then I'm going to need to have some stuff from keeping track of, okay, what is the current time? And there's different units we could use for keeping track of that. I'm going to keep track of the current time in seconds, which will also probably be useful to have a starting hour. Start time in hours. So we might start it at 4 a.m. So we'll have our current time in seconds. We will also have our current time in hours, which will be current time in seconds divided by 3600, because 60 seconds in a minute, 60 minutes in a second. So, okay, that gives us a good amount to start with. Our current time in seconds ends up being our start time in hours multiplied by 3600. And then we're going to have update time. I think update time. So we'll call that normally down here as well, but just to ensure everything's synced up at the very beginning. So our update time, well, what it needs to do is firstly our current time in seconds has to increase by time.delta time multiplied by our time multiplier. Now we want to have that restricted to, though, within our hour range. So what I can do for that is I can say current time in seconds is equal to, so I do the update, and then I do percent hours per day, but I have to do that hours per day times by 3600. So this modulus will return the remainder. So if we tick over to the next day, this will actually subtract that. And for whatever reason, if we set that time multiplier to something massive and it jumped ahead huge numbers of days, it'll bring it back always down to within that 0 to hours per day range, which is good. So we're updating the current time, and ensure is within correct range. So, okay, so far so good. Now we need to change and rotate and position those lights. We also need to control which one is actually active in terms of shadows. So we need to know whether it's daytime or nighttime. So I'm going to make that one public. I'm also going to have a public bool, is daytime or is day. So it's day if the current time in hours is greater than or equal to our sunrise time, and current time in hours is less than or equal to our sunset time. Then it's day. Nighttime, I'm just going to make that it's the reciprocal of if it's day. That ensures that we don't. If I wrote the condition again, there's a chance I could make an error, and it could think that it's both day and night at the same point in time. Less than ideal. So I'll often write ones like of this, so that I'm not writing the check again. Because what that allows me to do is then down here it becomes quite easy. Okay, well, sunlight data. Shadows. So if we have a look in terms of the different shadow ones, we do have our enable shadows, which sunlight one is enabled, F is day, and moonlight data enable shadows is night. So now only one of them will ever actually be active. Now, the possibility, though, with this is that we could have one active and then we turn the other one active on at the same point in time. So we want to kind of actually do the turning off first. So we'll actually take a step back with this, because otherwise we would get, at that frame where it transitions, we would actually potentially get that exception happening, and we want to try and avoid that. Well, it's actually an error rather than an exception, but it's still not good. So what we will do is moonlight data, enable shadows, false. Sunlight data, enable shadows, true. So we do the turning off always before we do the turning on. Is just going to ensure that we can't ever have two active at the same point in time. So that's good. So, okay. Update the shadows. So far so good. Now we need to rotate the system though. So I'm going with a very simple setup where the sun and the moon are anchored together. You could go for a setup where they are not. But what I'm going to do to begin with is position them so that they are exactly 0 and 180. Because they're now, okay, so 0 is sunrise. Positive numbers are during the daytime. So 0 to 180 will correspond to during the day. And then 180 to 360 corresponds to nighttime. So that means that what I can do is I can work out the progress through the day and the night. So I can check and do a little bit of stuff here. So if it's daytime, well, that means it has to be between and daytime's actually the easiest one. So I can do a mathf inverse loop of our sunrise time, sunset time, and our current time in hours. So that will give me a 0 to 1 value. That will correspond to 0 will be sunrise, 1 will be sunset. So I would be able to do a pretty easy setup where we have our sun and moon system, and I can actually just go and set its Euler angles is a new vector 3, and it's just going to be that. So that will work for our setup with daytime, except we would actually multiply that by 180. So 0 to 180, that'll work for daytime. Nighttime is a little bit trickier because nighttime we have a portion that's at the end of one day and a portion that's at the beginning of the next day. So what I need to do is, okay, well, if our current time in hours is greater than our sunset time, so we'll have hours into night. So in this case, hours into night is our current time in hours minus sunset time. So that's good. Otherwise, we must be in that bit before sunrise. So what we can do is we can say, okay, hours into night would be the current time in hours plus hours per day minus sunset time. So we add in the chunk of night up to midnight, and then we add in however far through we are in the day. So that's good. We've got the hours into the night. We need to, that's a bit of a trickier one for our inverse looping. So we kind of need to keep track of how long is a day and how long is a night. So what I'm going to do is, because this is a potentially useful thing that we might want to calculate at other times. So public float day length. Well, that's sunset time minus sunrise time. And night length, again, to avoid there being potential getting things wrong, hours per day minus day length. That just ensures those are always going to be complementary, which is important. So, okay, we have hours per night, which means we can then do sun and moon system. And so it is going to be 180 to 360. So what I could actually do is sun and moon angle. And this one, sun and moon angle, is 180 times by, so this will just make it a little bit cleaner and neater, the code, makes it a little less complicated. So whereas here, sun and moon angle is 180 plus 180 times by hours into night divided by night length, which will give us that same 0 to 1 value. So that looks good. Then sun and moon system, Euler angles, we can just set that to our new vector 3, sun and moon angle, like that. Okay, so we've got that set up, so we can now test this out. And what we're going to do is, so it should start when it's nighttime. And so we'll run that, and it should start, so it's 4 a.m., so it should start pretty dark. And it's going to, I can actually increase the time multiplier. So we'll make time pass even faster. So we can see the moon is setting there. And we can see our rotation, so we're starting to get our dawn. Now, in the scene view, it'll struggle a little bit, but that's okay. We can see it's progressing through. So scene view does take a little bit to get caught up, but we can switch just to the game view. It's going to look a little bit better. Scene view may take a bit to sort of catch up with it. We can see our rotation is changing, so that's good. We can also make it that if we wanted to, time passes even faster. So we've multiplied it by 4. We could multiply it by 4 again. We can see our shadows are moving, which is good. Sun and moon system, we're approaching midday. Shadows are almost directly overhead, which is again what we would expect. And then we're going to be heading now towards our sunset. So we should see the sun starting to set. And slow that right down if we want to. And we just see the sun slowly setting there on our system. So we've got a time of day system now where we can control what's happening with the time there. We have our weather being able to vary, it's changing the sky. That's also syncing into adjusting things like our lighting and that, which is looking really cool. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you're looking for the code for the project, there is a link to that in the description below. That code is freely available, you can use that in any of your own projects, commercial, non-commercial ones. If you've got any questions, chuck in a comment below as well. If you're looking to try and easily find other videos, I do have a video archive set up, which is the link to in the description. That's a searchable set of all of the videos. You can search based upon descriptions, things like that. And finally, if you're looking for other ways to support the channel, I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.